All right, so one of the most typical examples in stoichiometry is how to find out the limiting reagent. And problems like that typically present you with the initial quantities of reactants. They react according to a reaction. Notice that it's balanced. It's a balanced reaction, and it's asking for uh, what concentrations or what quantities of reactants and products you're going to end up at the end. So it's likely that there will be some limiting reagent, that is a compound, the substance that you run out first. That means there'll be some leftovers of the other substance, and there'll be a quantity. Okay, so the strategy for finding out limiting reagents, so let's try to be as systematic as possible. In this case, the reaction, it's a very well-known reaction, the synthesis of ammonia. Ammonia is used in many industries. Fertilizers, for example, it was a revolution, the way we can synthesize ammonia from hydrogen and nitrogen. In this case, we're mixing 10 moles of nitrogen and 10 moles of hydrogen. So the way we will do this kind of problem is, well, let's set up what we call an ice table. And we will write it this way. Ice in this case states for initial, change, and end. So what are the quantities that we have initially? Initially, the problem says that we have 10 moles of hydrogen and 10 moles of nitrogen and 0 products. Alright, the question is, how much change are we going to have here so that we subtract the initial from the change and we get the end? And change initial. Okay, so how do we know that? Well, let's see. Let's say that option 1 could be that we run out of hydrogen first. Okay, so if we run out of hydrogen, it means that if the 10 moles of hydrogen react with nitrogen, how much nitrogen do I need? So 10 moles of hydrogen, the reaction says that for 3 moles of hydrogen, 1 mole of nitrogen reacts. This means that I need, for the 10 moles of hydrogen, I need 10 over 3 moles of nitrogen, which is 3.3 moles of nitrogen. The other option would be that I run out of nitrogen first. And let's see how we can incorporate this data into the ice table. So if I run out of nitrogen first, it would mean that 10 moles of nitrogen, according to the stoichiometry, 1 mole of nitrogen reacts with 3 moles of hydrogen. This would mean that I need 30 moles of hydrogen. So only one of these two options is possible. Notice that in this case I need 3.3 moles of nitrogen, and here I have 10. But this option, I need 30 moles of hydrogen, and in here I have only 10. So this option is not going to be possible because it requires too much hydrogen. So I'm going to use this option. That means I'm going to run out of hydrogen first because it's the only possible option. So what is the change? I will run out of all of the hydrogen. These 10 will be gone, and I will consume 3.3 of nitrogen. 3.3. So what am I going to have in the end? 10 minus 10 is 0. 10 minus 3.3 is 6.6 moles. And how much do I have of ammonia? Initially I have ammonia, 0 ammonia, so I need to use this same number because the hydrogen will dictate the quantities of the rest of the components in the reaction. So according to the stoichiometry, 3 moles of hydrogen give 2 moles of ammonia. That's 2/3 of 10, which is 6.6 moles of ammonia. So there will be 6.6 created plus 0 is 6.6. Okay, so this is a fairly systematic way to identify the limiting reagent, and I hope this makes sense.